Good evening, everybody. Welcome to League of Extraordinary Inventors. I'm your host, Mike from Faraday Research. It is Friday night. It's July 19th, 2024. Welcome to the show. With me on the air tonight, I have Philip from Montreal. And we'll get right into, some of the headlines that's kind of been stirring up some stuff. We could start with the big Microsoft crash this morning that happened. It basically crippled our company for like almost half a day because we use so many computers for everything. And it was kind of a tricky, punching in the morning, logging in on your jobs and all that stuff. We couldn't do any of it. All our computers were like the blue screen of death or the black screen of death, whatever you choose. So it wasn't until about noon when we pretty much got everything back up online. And I guess the other big one was, Trump getting shot at last week. I guess that's basically the headlines. I've still been working on the battery project. I kind of did. I'll just show you really quick here. I'm working on a special polymer, uh, epoxy. This one was a fail, unfortunately, but I'm learning. So hopefully, when I get that figured out, this will be uh, kind of the design that I'm going to be doing for the new battery, or the cell technology I'm working on. So yeah, it's testing, and you're going to get failures from time to time, right? So um, oh, we got someone else here. His name's Justin. We're going to add Justin to the show here. Hi, Justin. How's it going?
Doing good. Hey, Mike.
Excellent. Thanks for joining the League of Extraordinary Inventors. Thanks a lot for coming on tonight. So we got Philip here. He's in Montreal. Where you live, Justin?
I'm in Michigan.
Oh, you're in Michigan. Oh, you're not far from me. You're only about a couple-hour drive from me.
Where are you at?
I'm in Toronto.
Toronto. Yeah, that's close to 2 hours. 3 hours.
Yeah. So yeah. We got Lulu online. Hi,
Hello.
Lulu.
Hi.
We got Justin here joining us. I guess this is your first time on, right, Justin?
No, it's second time. About
Second?
6 months ago, I joined when you just started up, like the first month or two.
Oh, right. Okay. Yeah. My apologies. I had to do so many shows, you start losing track of how many people has been on, and then it takes somebody to kind of hit me across the head and jar my memory. I guess we'll start with Philip. Maybe just kind of give us an update what's going on.
Yeah, like I was saying before, I didn't do major improvements on my anti-gravity experiment right now, but I did apply for some NATO projects, some NATO project. They're looking for people that can innovate in energy or any other field. I think you said you are for NATO. Is that it?
Yeah, I'm NATO certified. Yeah, I
Yeah,
got all my clearances for NATO.
yeah. So I forgot the name of the project, but it's NATO oriented, and it ends in 20 days. So I had to hurry up to apply for it, and like I was saying, I'm following my entrepreneurship classes. I'm learning a lot of interesting things, and with the blue screen of death problem this morning is the perfect timing for me to do marketing, because my software, that's exactly what it fixes. It fixes crashes and memory
Right.
leaks. It's the C++ superset thing. So that's exactly what it fixes. So I started doing promotion and contacting big tech and things like that.
Yep, that's cool. That's perfect timing for this, and maybe you can put out some campaigns to drum up some business.
Yeah, exactly. So That's what I'm doing, and I'm looking forward for the experiment in the scientific laboratories and the professional laboratories in the next month, which
Right.
is in a week and a half. So
That,
time is running fast.
yeah, that's cool. That's really cool.
Yeah.
Right on. Yeah, it takes time for some of this stuff to get together, right? Sometimes it'll take 6 months, sometimes it'll take a year, but if you keep at it, and eventually you'll get somewhere, right?
Yeah, exactly. I mean, I've been working on the theory for 14 years, and
That's a
now,
long time.
yeah, with APEC for the last 3 years, and now finally this year, I'm starting to get results.
Yep.
So it's 14 years, man. It's like 3 PhDs.
Yeah, you learn, right?
Yeah.
Yeah,
Yeah,
I've been at this over Unity thing for like 20 years.
20
I
years.
start Yeah, well, I started kind of like back in the early 2000s with Brown's Gas, and I had the bottle in the car, and I was able to increase my fuel mileage and totally eradicate my whole exhaust system from noxious fumes, right? So
Okay.
I actually had a friend that had the same thing. He actually got the test done, all the readings for carbon and all the pollutants in the that come out the pipe. Everything went to zero. He wasn't reading anything, and
Okay.
just water vapor was coming out the pipe. So that's a whole show all in its own.
Okay.
Uh, Lulu, how you doing? You got power.
Or yes. Actually, I got it the second day after the show,
Oh, okay, good.
so I didn't even have to make that bit. The electrical bit to
Yeah,
put on the end of the generator and then plug it. Yeah.
yeah, that genset. Yeah,
So no flooding.
No, we had a hurricane.
Yeah, but you had no flooding in your house.
No flooding. No, luckily.
Okay, that's good.
Yeah, but I still have a lot of wind damage. Like I'm still waiting for the adjuster to come and so they could file the claim. Like half of the roof shingles are like gone. So hopefully I don't get any heavy storm. Until then. But
Okay.
yeah, but everything's it's okay. I'm gonna
that's
be
good.
a week. I'm gonna go for a whole week. I'm gonna be actually close to like an hour away from Mike, I think, and then another hour and some from Drew. From the APEC people.
Oh,
Yeah.
okay.
I was thinking maybe I might take the drive, but we'll see. We'll only see. So next Friday, I'll be broadcasting from Florida Beach.
Nice.
Right on.
Yeah,
That's cool.
yeah.
Mm.
So we got Justin on here. He was on a while ago, pretty much when I started.
Remember his face, but I just don't like. You gotta refresh my memory on what you were talking about, like on the show.
Right. So can you kind of give us an update, Justin? What's been going on since we last talked?
You muted.
Yeah, you're muted there, Justin. You got the mute button on. Oh, okay. Oh, I don't know if you guys seen it. I did a prototype of my battery cell. I'm working on the composite type material. This one was a fail. Unfortunately, I haven't got the mixture done properly. I'm working out on the portions and everything, and
So
eventually,
a little power surge there, and so my
oh,
screens went out and my connections went out for just a
oh,
second.
We're able.
yeah,
We,
So
we
sorry
were.
about that. And I couldn't find my mute button because my screens were out. I got a couple big screens and then a laptop screen, so I could see a little what you were doing. But
yeah.
where I have everything on is my big screens are like from here to here, from here to here.
So it's been a while since we've spoken.
So let me remind you who I am. PhD in computer science, artificial intelligence, or programming languages for artificial intelligence. And then, I've always been interested in physics. In the last, maybe about 5 years ago, I spent about 5 years doing different things, including physics. And I got involved in a physics group on subquantum kinetics by Paul Laviolette. Basically, he wrote a big anti-gravity book, and the physics behind that was the subquantum kinetics. He was trying to explain, using his physics, all these different anti-gravity devices.
He's passed away now, right?
Yes, he just passed away.
Yeah, he passed away a year ago or something.
To December 2022.
Oh, okay.
Yeah, but we still meet. And so we had a group. It's been going 6 years plus. I think 2018 and early 2018. So that's like 6.5 years. So it's a physics at the subparticle level. You can describe it in different ways. Like, as a computational science, to say it's the subparticle level physics.
Right.
String theory, you got quarks at the subparticle. This is a different subparticle model. The biggest difference is that there was a simplification done in physics about 100 plus years ago. For spin, they made everything discrete, 1, 2, 3, 4, as opposed to, the reality of the continuous world, because they didn't have the computational tools. We have the computational tools. And so Paul, he, recognized that. He recognized that there were chemical models based upon fluid dynamics, but it's a reaction diffusion fluid dynamics that can be used to model particles, the ether, light, all at the same time. So it's a major simplification of the model. Although the computation is more complex, the model is much simpler. It doesn't have paradoxes and singularities in it. You don't need relativity. You don't need, quantum, etc. And so if you're doing continuous versus discrete, you have gradation physics as opposed to quantum physics. So things jump from one gradation to the next gradation, but there's play within the gradations because everything's continuous. And there's lots of phenomena in the world that have those properties.
Right. So I remember you talked about that before. I have a very similar paper. I wrote a very similar paper. I put in the chat right here. I talk about quantum physics, the strong and the weak nuclear forces and all that stuff.
Yeah, we don't need the strong or the weak nuclear forces at all. All you need is gravity and electromagnetics. And electromagnetics is basically just the flow of exon, yons in different directions. And there's a lot of evidence that, and also the conceptualization of electric flow, they don't really know which direction it goes. It seems to go both directions. And with this model, exons and yons are flowing in opposite directions in a circuit.
Now, I have a quick question for you. If you create a substrate for that activity, will you get energy flow, say from an anode to a cathode?
Okay, so you're jumping ahead. So let me get to that. Okay. And so I'll give a little more background. So I also, as an artificial intelligence, my specialty was in meta-level reasoning or reflective models. And so meta-level reasoning is you have one reasoning level on top of another reasoning level on top of another one, so that this reasoning level reasons about this one. And so I just applied that to science. And then I looked at all scientific models and saying, because in computer science, we have software engineering where you can actually do quantitative measures of different models or different physics or different scientific models. So each one of them is basically a reasoning model. And so you can actually create quantitative measures. So that's what meta-level science is, using quantitative measures to measure different scientific models. And then I, look at, relativity or subquantum kinetics, and then I can do a comparison between them because you can use these quantitative measures. So I combine that to look at a lot of different types of science with the subquantum kinetics physics. And then we have a group on Saturdays. It's like 4 or 5 hours of meeting. We have breaks every hour or so. And so we talk about the theory, we look at simulations, we look at related phenomenon, and we're starting to get into engineering. That's why you might see on my little screen, it's vortical ether engineering is underneath my name. And because I wanted to, say that because the spin, you have not just spin in the particles, you have a spin of the space around it in the ether. And so that spin, creates light, because light has this vortical behavior in it. Sound, it has vortical behavior in it. Everything's got vortical behavior, from between galaxies, interconnecting galaxies, to spiral arms, to within the spiral arms, you got Birkeland currents, all the way down into the spiral power, the spinning patterns in the solar systems, etc. It goes all the way down to the particle, subparticle, and the even in the human body, they found that the heart actually spins the blood up, and so that even within the body, you have vortical behavior that's actually providing antigravitic effects to help blood flow in the body, etc. It basically is the core of life, this vortical behavior. So that's sort of vortical. So coming back to your model, first of all, I wanted to talk. It was Phil, or I forget your name.
Philip.
Yeah, Phil.
Yeah. So you said you've been shown 14 years. Paul, he originally had his model like in the 70s, and then he wrote papers, and he got papers taking up full journal, a month's worth of a journal, full quarter's worth of a journal, so basically a book, and then he turned it into a book, and that was in 85, and he's had different versions of the book all the way through 2020 or 2022, if he put out his last version of the book. And we're going to create another version of it, adding some, fixing up fonts, indexes. He had last printed copy was version 3. Version 4 and 5 were strictly online. We're going to make another printed version for version 6. And so think of that from the 70s all the way to the 20s. So, working on this, he worked on it 50 years. So 14 years, just getting started.
Yeah.
Know more about how are you using artificial intelligence?
So meta level reasoning. Okay, so you have to have one level reasoning on top of another. So the how I'm doing it is the meta level is basically software engineering quantification measures on top of looking at all scientific models. So you take the scientific model and you create quantitative measures on that model, and then you compare the different scientific models based upon the quantification tools.
Sorry, like the spin rotation of a particle or an atom, like if it spins up or down, like the nuclear dynamic orientation of an atom, or is that what you're doing?
So we're not changing most of the physics. The big change in the physics is we're going from discrete to continuous. So that spin can vary a bit. Okay. Yeah. So when you spin things up, so as opposed to just having a spin of 1, you have a spin of 1.01 or 1.02. And so you get better behavior. When things are spun up, and there's other physicists have written other books on how that enhances life growth. It enhances chemical interactions. So it's basically spinning. When you have things spun up faster, the particles spin up faster, they react more effectively.
Because I know that when you put a magnet next to a plant, it's going to grow faster. So do you think that affects in any way the chemical?
So let's get to components. Okay, so there's a lot of different components that have spin. Capacitors actually have spin. Crystals have spin. Light has spin. Different variations of light can have spin also. Sound has spin. Pyramids actually have spin. The pyramids were used, thousands of years ago, and experiments have taken seeds to the top of pyramids, and they found that they can take those seeds and then get those seeds to grow like 3 times faster than normal seeds. You also, people who spin up the water, they get spin in water and use that water, and they get better growth there. So everything's coming back to spin behavior, which is part of the physics model we have. So we have spin not just in the particle, but in the ether around it too. So you're also affecting the more general ether, because everything is reacting and diffusing exons, yons, and geons. There's some other particles in there, but those are the ones that we predominantly work with.
So I have a quick question for you. So if you're able to manipulate the ether around you, what ways are you able to actually do that electrically or mechanically
Okay.
or
Yes.
everything?
So that's why I used the term vertical ether engineering, which I didn't have last time I talked with you.
Yeah.
But not engineering. We had vertical ether, but not vertical ether engineering. That's a newer term. So what we've been looking at is, we looked at where do we see this type of behavior, antigravitic and other types of things that you can sort of see when you're seeing vertical ether. And so what I use is, I've got some devices here. I'll just use to show you the DIY one. So because it's pretty easy. So we got 2 layers of crystals. Here, 2 layers of crystals.
Yep.
So that's actually crystal plates, a special order. And then you got capacitors here. You got 3,000 farad at I think 25 volts or something like that. It's the material. Notice that there's no electricity flowing in them.
Right.
But what you see is the materials themselves have they create extra vertical behavior. And I've tested a lot of different types of capacitors, handmade, etc., orgonite, what have you, because orgonite is basically just a dielectric next to a conductor, and they put things in there. And so all of these things you see, orgonite, etc., everything's basically getting the dielectric next to the conductor. And so one of our group members is just finishing his PhD in chemistry. And so we've been talking about the chemistry of how that happens. And so the conductor has the conductor is sort of like a space of all of the electrons that can flow all the way around. And if you put it next to dielectric, you've got some of these electrons far down in the atom, and they can be sort of attracted up. So you're by putting the materials next to each other, they're continually pulling those electrons up. And the better that you do, you get the more electron pull. And so that's what's creating these spin.
So what you have on that device there is quartz crystal, and then a plate, and then
this is a LED. Okay, because light, and particularly varying light, we're changing the frequency. So you're creating more spin by changing the frequency. But light itself has vertical behavior in it. So we did experiments, so people who are sensitive to energy, but we also did ice freezing experiments. And there are a lot of people who do ice freezing experiments on orgonite, that type of thing. And we did similar stuff, but I was able to compare the different materials, the better crystals, the better capacitors, the better LEDs, etc. And and what combination worked the best. And so we found that you needed the 3 different layers. And it also softens things up a bit, because some of the things we're doing, scalar waves, etc., sometimes the light can be, harsh, but it becomes soft. But you actually see it in the freezing ice, because you get a tighter and tighter spiral in the ice, clear around it, and then cloudy. And I got some pictures online. We can show it later, but we're just doing summary now. So we're seeing that this type of combination is good. And now we were trying to figure out why you get the physics in the capacitors, the orgonite, or we call it orgon. Crystals, light, and orgon. I call it CLO, crystals, light, orgon, flow. And so crystals, their natural structure, they have a spiral structure. Their matrix is spiral in nature. So that's how you get the vertical behavior. And the light itself has vertical behavior. You're putting out vertical field, but because you're varying the light frequencies, you can see it's going back from one light frequency to another. It's going to create additional, because you're continually changing. And I got some others that have even more.
So that device you have there, what do you do with that?
Health. My voice has gone from like a tenor down to a bass. Okay, it clears up your lungs. Okay,
really?
So you use it for health purposes. I do get colds, but they last 15 minutes max. So I can go to work, start getting a cold. That's when people were on working remote. And start getting a cold, and start feeling under the weather. You come home, put it on here, and 5 seconds later it's gone. Now really bad colds come back, going real bad colds. You might have to put it on for 5 minutes to get it to go away, and then it might come back after an hour, and you might do.
That's crazy.
Same thing with
3, and then you're done. Now that's me, because I have an extra one on all the time. My buddy, his isn't quite as strong as mine because he used different parts, and he still got cold, and it still lasted. It did, maybe a couple days.
So the LED light you're using, is it like a grow light?
These are DIYs. This is for photography.
Oh, okay.
$3 LED. And on my website, I have a list of parts that you can order and sort of instructions. They're a little old. I sort of tried to update them to the newer parts. Now, some of these are special order, so you'd have to go to Alibaba and order like 20 of them instead of just 1 or 2.
Right.
Yeah, you can. There's a DIY. It's on clo.life, CLO.LIFE. So you can do your do on.
Yeah, you could put that in the private chat for me, and I'll definitely post it there.
Right, and so recognize, this is everybody else. This is just research, so everybody can do whatever they want.
Yeah,
it's their responsibility.
No, that's very cool.
And what is your definition of ether?
But we're in our group on Saturdays we talk about anti-gravity, because that was a big thing, because Paul's book on antigravitics was like one of the top ones. He's like 40,000 sold. Right. And so anti-gravity, we also talk about energy. And so that's what brought us to you, Mike, because we saw your work. I know that you subscribe to our Facebook group.
Right. Yes.
So we hear from you all the time. We look at what you're doing. And so, this is the second time I've come. And I've told the rest of the group, I don't think any of them made it yet. Our group is made of people in the UK,
right,
Canada, and the US. And we get people from other countries too coming in, Germany, Sweden, etc. Some Far East too. And for the people in the UK, this is way too late. Not going to happen. So
they're what, 6 hours ahead of us, I think.
Yeah. So the electric, because I'm weak on the electricity, because I don't, I don't have the experience you guys have. I do a little electrical, but not to the level you guys. But one of the things I did see that was interesting, because we looked at your device, we called the Don Smith device, because he did a light up on some of the
right.
Referred to him. And basically it's one spiral around another, vortical behavior.
Right.
And so just recently I saw that at one of these big, WEF forums, the guys who are trying to control the world, whatever. But there was the Korean company that came in, and they had a Don Smith device.
Yeah.
And they had AI attached to it, as opposed to spark gaps or anything like that.
Right.
I don't know if you've seen that one or not.
No, I haven't.
Let me put the link in.
In the private chat there.
Let me put the link in the private chat. It's over here. I just pulled it up.
Bookmarking all this stuff here.
It reminds me of a doctor in the early century who found a cure to cancer using electromagnetic waves at a certain frequency.
Yeah. So the thing I told you about the heart spinning up, it basically being a vortical at ether engineering device, was because there's medical doctors I've been in contact with too, and they have stuff online, et cetera, and they have books, et cetera. And so there's people who are doing videos on them too. They notice that when the artery closes, when the heart pumps, so it's not pumping blood around, but they've actually taken that same shape that the heart is, put it in water, and do a pump, and they find that a spiral in the water happens.
Oh, cool.
So the heart is basically spinning up the blood, creating vortical ether in it. So all the particles are going faster, just like the device. Okay, it's spinning everything up. And then that blood goes through the body, and the blood goes all the way down to the little veins and the little to the small parts, and stops. And then it starts again. So it can't be pumped that way. If the pump stops it, something else is bringing it up. And so the theory, and so there's there's the fourth phase of water chemistry guy, Pollock. So that's sort of what they were thinking. We're a level below that, and we're seeing that there's antigravitic properties when you got extra spin. And so that extra spin is enabling the antigravity to bring the blood back up in trees to take the water all the way to the top, et cetera. So you got some antigravitic properties in that extra spin. So health, you need spin.
Right. Now, okay, so when you're creating this spin, you're drawing in orgone energy like Wilhelm Reich was working on?
So William Reich basically had just a big capacitor.
Right.
He had wood and steel wool,
right,
capacitor and dielectric, and he lifted it like a capacitor.
Yeah, I built one of the cubes, dielectric accumulator. So basically, it's like a capacitor without the outside plate.
So pyramids do the same thing too. Shapes can do that because they've got, the rocks that are made out of. They have conductor dielectrics in the rocks too, and the shape enables that extra vortical behavior. So shape one thing, sacred geometry. So there's lots of different things that we see out there that seem to have these anomalous behaviors, and we're just basically, it's vortical ether. And the only change you're doing to physics is basically spin is continuous as opposed to discrete. It's really that
right.
change.
So say like if you were to make like a small pyramid, would that be a dielectric material that you would use in order to create the spin?
You can actually see that because I haven't explored pyramids, but the Russians did, and they found some very anomalous behaviors. They built a pyramid out of much cheaper materials than all that stone.
Right.
Okay. They used some polymers or what have you, and they made a big pyramid. People could go inside of it. It was basically like a big tent, but it was at 60 degrees, not 30 degrees, and they had great results. You can look that up online, and you can see that there's a lot of very interesting behaviors around pyramids, et cetera.
So
and how it controls water, et cetera.
So more like healing effects, or even if you were to put water inside that pyramid, would it change the structure of the water?
Yeah, it would be structuring the water. You actually can look at the Great Pyramid. It's actually in the form of a pump. There are people who've looked at it and say, hey, this is exactly one of the old types of the pumps. So, and they actually had waterways going around the pyramids. And you could actually see that water was being taken into the pyramid, pumped up, then back down. And so they irrigate the crops. So the pyramid has a very functional purpose. It wasn't for religious things. It was economy to help crops grow better.
Yeah, because I knew back in history, Tesla was actually made more than one trip, I believe, to the pyramids, and he was studying a lot of quartz crystal materials in his late 70s. So yeah, it wouldn't surprise me if he was onto this stuff.
So there's the other part is that you've got the Ark of the Covenant, and John Hutchinson.
Yep.
So he actually did a project that they actually did video.
Built it. Yeah, I've seen it. Yep.
And he basically did the Ark of the Covenant with cheaper materials, just like the Russians did the cheaper pyramid. And just like you can do the same thing, get vortical ether out of much simpler things than having to build a big pyramid. And so, the whole thing is to understand vortical ether. It's a real simple realization. It's continuous as opposed to gradation. And then look at all the anomalous behavior and see it's all related to this vortical properties of chemicals or of chemistry, et cetera, or light or what have you. Everything's got vortical behavior. You're working with the Don Smith device. You got two electric things going. You got a lot of vortical behavior. So we're trying to investigate all those different components, identify all the different components that can have vortical behavior, chain them together, improve the components. There's this one, I don't know if you're familiar with APEC or not. They're an group.
Yeah. Oh yeah, we know.
Yeah.
And so there's one group there that they're really excited about because they're getting close to 1G in their experiments, and the guy is a NASA electrostatics guy. And so a lot of people electrogravitics think it has to do with electrogravitics, and so and people that's been true for like 100+ years, going back to Townsend Brown. But my view is that no, it's all the vortical behavior associated with it that electrogravitics creates, the electrostatics creates vortical behavior, and you want to try and optimize the vortical behavior to get the better electrogravitics
Right.
behavior.
So, did you see my Don Smith device with the plasma tower?
I don't think so. I've seen a few of yours, and so I'm focused on the physics.
Right.
We do physics simulations too. We do computer simulations of
Okay.
components and how can you actually get those particles to be created? How do the particles react?
Right. So I got basically I got the plasma tower. It's about 12 inches long, and I have a tube around it that's lined with basically tinfoil, and I'm able to grab the electrostatic charge that is being created in that field around the tube and capture it and dump it into a capacitor and light up a 60-watt bulb.
Okay.
Just by catching the flux that's been created by the tube.
So the whole theory is the better that you control the vortical behavior, and so the electrostatics is another thing that is another vortical ether component. So the more and then those spiral wires around each other, that's more vortical behavior. The better you can control and manipulate the vortical behavior, the better that you're going to have the spin. Better you're going to have the antigravitic behaviors. Better you're going to have energy being pulled. So there's one other video that I put online. I have meta level science videos, and one of them is on energy. That all energy is perpetual. Okay, all energy is being pulled from the environment, whether it's solar, wind, geothermal, hydro, or even burning fuels. In the chemical itself, when you burn it, it releases energy. And that continually changes. You're always releasing energy. It's always perpetual as long as you have the materials there. And getting materials to the burning fire, what have you, has nothing to do with the energy equation. The energy equation is completely about those fuels being burned. And the same thing goes for nuclear or any type of energy we have. It's always perpetual. And so, you're pulling energy from whether it's particles or atomic level or bigger things. You're always pulling energy from the environment, and so what we're looking at is at the subparticle level that we're pulling energy from the ether. Okay, people say dark matter, etc. But working with these components, working with vortical ether energy, we can pull energy out of the ether. So the ether is the environment where we're pulling energy out of. So that's the model.
And basically what you're saying is that it's a lot easier than a lot of people might think.
Much easier, much cheaper components. All you have to do is change your mindset, which is a very difficult thing for people to do. They spent decades thinking relativity and all this. They learned all this stuff, and it's very tough to get around that. Just going back, you can make changes to some of these models that are 100+ years old. Just change discrete to continuous, and it solves all these problems.
Right.
It's simplified physics. Most of the physics that all these complex stuff disappear.
I agree. I 100% agree with you. But what is your definition of ether?
So the subquantum kinetics book goes into that, and it's a complex topic. So I'm not going to go over it. I'm going to say go look at the subquantum kinetics. We're just about to publish a hard copy, but electronically you can get the 5th version. But we're just about ready, like in the next month, to publish the 6th edition, and it goes into that in quite a bit of depth. Paul, great book, fantastic, great theory, brilliant guy. As far as I'm concerned, most brilliant scientist out there. And there's a lot of brilliant scientists, so there's a lot of people who are just second and third, real close. So anyway, but still. So basically, fluid dynamics, and you've got these etherons, exon, yons, and geons, and they react with each other. And so you've got this reaction, and the diffusion is you put something like a blue dye in water and it disperses. So everything's just diffusing of the same type, diffuses within the water. So exons diffuse, yons diffuse, geons diffuse. And then, and they're all these reacting with each other. So they're changing from one type to another, and they're sort of like different states. And you actually see the chemists can actually have things that actually have standing shapes. And so the model is that you have a standing shape where you've got G on hills and Y on hills. So the motion of electricity, or the motion of objects, gravity, has to do with diffusion. So particles are pulled towards each other because there's a diffusion. There's a hill over here and there's a valley over here. So these things want to move, and they're sort of standing waves. And so because they're have a dearth of geons, they would want to go towards where there's a lot of extra geons are sort of pulled. And so there's more detail on that. That's very abstract, and I probably got a little bit of the variation wrong, but it's that's the basic model. So you've got all the motions in physics, and we have computer simulations doing some of this stuff. And I worked on some of those. But it's complex because you got to think about it. Got to be.
I'm just going to scoot away for a quick second. I'll be right back, guys.
Yeah,
just carry on.
5-minute break or something like that, or does everybody?
No, just me. I'll be right back.
Just
the rest of us.
Be in exact chambers, or is this just computer simulation, or do you actually?
Yeah, we're doing computer simulations, but there are people who do chemical simulations.
Okay,
yeah.
so all right,
so this is behavior seen in the real world, and it's when people were thinking about the ether, they were thinking about, because 100 years ago they had simpler models, so they really couldn't think, oh, things react and diffuse. But since then, 100 years or 50, 100 years later, people started seeing this in chemistry and in other places and saying, oh yeah, we can have these more complex models. And so that's basically what underlies subquantum kinetics and the model. And basically the theory is it's what's underlying all the physics. It's underlying everything that is us in the world.
So if you were to do the experiment, how would your setup look like, or how would you?
So you can't do it direct, but and it's basically vertical ether engineering, or basically experiments that I run, and whether that be for energy purposes like the Don Smith device, whether it be for health devices, whether it be for anti-gravity or other purposes. So the whole thing behind models, as an artificial intelligence specialist, the model is a tool to use, and there are a lot of different models you can use to do the same task. And so you want to measure your tools, your modeling tools, to do different tasks. So there's this debate of nominalism versus realism. Some people think that the ideas in our head, our theories, are reality, whereas the nominalist is, no, our models are just tools. They're very inexact. And being a computer scientist who has to take things from the real world to physical sensors, to then models of those sensors, and then to other models, and then to a human user interface, so it's understood in the human mind, you're dropping many layers of infinity all the way through that. So there's absolutely zero reason to think that our ideas are real. They're basically nominalistic tools.
Is your AI model able to understand mathematics and everything?
So there's a lot of AI tools out there, huge variety, and they understand mathematics in different ways. People have been creating mathematical models all over the place for different purposes. And if you actually look at mathematics, and this is computation, and just to give you a simplest example of where mathematics falls on its face, right at the beginning, look at division. Can you divide by 0? It's a singularity. You can't. So the mathematical model breaks down. It's an inexact tool, but it's a useful tool nonetheless. And the more complex your models get, the more places where you have issues. For like relativity, it's got paradoxes and singularities in it that just make it unfeasible. Yeah. And there's like 4,000 research papers against relativity.
In computer science, you call that a segmentation fault.
Computer science has lots of, every computer model has lots of gaps in it, and so that's what gives us jobs. We make I do software for a living, and so we build software and we do the best we can, but there's always going to be gaps in whatever model you create. But refactoring is sort of the rule of software engineering now. When you're going through your computer models, you're always refactoring your software. It means you're always updating and changing the model that it has, improving the model it has as you're continually improving your software. And
Yeah,
you have different generations of software where people are using a better software modeling tool to another one. So the coding is better each generation, and people are continually improving. But you always take along some of the old software sometimes to
yeah.
keep things running.
There
Um,
are, well, I guess you write your code in Python.
So I read code in everything. So I've written code in Python, JavaScript, Java, C. There's dozens of languages that I write programs in. So there's it's an ongoing process. You could call me a polyglot, but it's basically they all look the same to me.
Yeah,
It's just check the syntax in this language versus that language.
yeah. So interesting. Because I have a model also, and I mean my theory, like I was saying earlier, but for me, ether is just a virtual particle density, and that's as far as I go. Maybe that can be explained better, but
But yeah, it doesn't matter if it can be explained better or not. The thing is, it's a nominalistic tool. So can you use it to build with? And that's the whole key. And so we're using the subquantum kinetics to not just do simulations. We're also trying to build tools with it. So that's where I'm focusing on vortical ether engineering, because what you want to do is you want to look at all the components, and just like with electronics, you want to take those components and chain them together. Okay,
yeah,
crystals, light, orgone, or sound, or other components, electrical. You can have electrical coils, etc., or pyramids, or other types of structures. And so that's sort of the thing that is the key. Can you use your model to do something, to create tools? Is it a good utilitarian tool? If it's not, then you're just taking up government money, like string theory or
yeah,
particle
exactly,
physics.
yeah,
Not really using them to do tasks.
yeah,
They're using particle physics and string theory to make money for the researchers and other companies that are making some of the tools.
yeah. It's an industry.
They're not building anything with them.
You
So
know,
if your model can't build anything, then
my theory with them, with the Perimeter Institute and the Kavli Institute and all that is they they just the ultimate goal is to increase our deficit because they'll never find anything. It's impossible. It's even with the AI because the AI is trained on the mainstream. So they've been playing a pinball machine between string theory, Mon, and general relativity for the last 100 years.
yeah. So and all the things you're doing are very expensive. The components that I'm working with are very inexpensive, and the
Yeah,
components that you're working with, the coils and that type of thing, are very inexpensive too.
yeah,
And the whole thing is to optimize them. What's the chemistry of them? Why are you getting that spin? Crystals, there's a spin in the matrix. And with
yeah,
orgone, my theory is that you're continually, because dielectric next to conductor, you're continually pulling particles from the dielectric. The chemistry of the conductor pulls electrons up, and by all those pulls, you're getting an additional spin.
yeah,
But it's the chaining that works better, because if you put an LED next to the orgone, it pulls more spin than them independently. And so you chain them together, and then you get crystals at the end. You get even more pull, more vortical behavior.
I have a. I'll post you an article on the spin I was looking at actually yesterday. It's very interesting. It talks about. It makes me think about what you're talking about. So I'll just forward it in a couple of seconds.
You've got spin everywhere, and people are seeing it everywhere. Spin within light, etc. There's lots of articles. So send away. I don't know if I'm getting to it. I've got so many papers on. There's so many things on spin everywhere. So I don't know what the specific topic, but feel free to drop it in there. That I think you just gave it. So I'll put it in my notes.
Good. Yeah, just one
So I
second.
wanted to get to Mike's question, and so I
Yeah.
wanted to understand your question a little better.
Sure, that'd be great.
So you're saying in a substrate, and
Right.
so So spin in a substrate, as I said, you've got, dielectric next to a conductor. And I
Right.
just watched a video of a guy who's done research. He's trying to optimize HHO. And so he used, sort of like the steel wool or, this matrix where you could have, a conductor and a die. You could have the sort of a separation between the different charges. And so that the charges would go through the water. And it didn't work too well. He ended up just having one layer on top of another layer on top of another layer on top of another layer, just varying like a capacitor.
Right.
And he found that the capacitor had the best. And so what I found is the best capacitors out there, like these ultra capacitors, which are 3,000 farad, they
Right.
have the best effect. So look at some of the research. Now there's some other researchers. I forget the guy, Charles Bueller or something like that, who's NASA electrostatics guy. He's looking at how to get the best electrostatics charge because he's getting some gravitic behaviors there.
Right.
Electric behaviors there. And so, I'm interested in that because what are some of the best patterns? But then I just saw a guy who's varied all these patterns and found that just layers of plates.
So would it be fair to say that there's actually spin going on inside, say, like a power cell or a battery?
Yeah. So yeah, it's, as I'm seeing, what's the chemistry to get that spin? And the chemistry to get that spin, talking to the chemist is what's the difference between a dielectric and a conductor. He says, well, the conductor, all the electrons are sort of free, and because you got this entire matrix, not a spiral matrix, but a matrix, uniform matrix, it's got this spiral around it of all the electrons that can flow around. Whereas the dielectric that's next to, it's the electrons that can move are further down at the bottom. So that material, we're trying to figure out why you get spin. The only thing you think is because from a material perspective that they're pulling the electrons from the lower level, and it's a continual pull, and so the electrons are being pulled up and fall back down, pull up. So that's what's getting your additional spin. That's what's creating the additional spin. And what they found is when you put a charge into the capacitor, no current. You just put the charge in the capacitor to get the behavior. They can take the charged capacitor and still get the behavior with no current going through it at all. They were doing the research on the electrogravitics, and they found just charge it, and you're getting the behavior. And that falls in line with this vortical behavior model that we're talking about in the chemistry. So I don't know if I shy away from putting a charge in here because that's more dangerous. I want a safer device. And so, but that's a research direction to go. And they're also looking at other types of things. My own work is I'm looking at the LEDs. That's something that's easier to control with the small computer, which I do. I've got like an ESP32, what have you, that I used in some of the experiments to control LEDs. And then the crystals, I've gotten some of the different crystals manufactured, and we've been playing around with different crystals. And
how about Rochelle salts?
Say it again.
Rochelle salts.
I haven't used it. I don't know what they are.
Yeah, like they're Rochelle salt is very similar to the crystal structure, say in the quartz crystal.
I tried one other type of crystal. It didn't work as well as the quartz crystals. And you sort of think, hey, what are the type of crystal that's used, for other purposes? So we're using capacitors that are used for other purposes, and the best ones there.
Right.
What are the crystals that are the best crystals that are being used? They're using quartz crystals throughout electronics.
Right. So, now, any specific like shape of the crystal?
Haven't looked at that yet, but that's an interesting thing. So you can see we tried two different things, just crystal plates and crystal beads, and it seems like the best is to combine them. But we're also thinking that you can also etch things into crystals nowadays, and that's pretty inexpensive. So I haven't done any research in that area, but that would be very interesting to do because it seems like sacred geometry and other things seem to have these properties also. Just drawing things. But how
about calcite? How about calcite crystal?
Haven't tried. I did one of these crystal kits where you can actually grow crystals, and I tried one of those. Didn't work too well, but it still worked. But you could actually see how it behaved because we were looking at the freezing water. And you could see that it didn't behave as well, but you still got some behavior out of it.
Yeah, right on.
What do you think of the time crystals?
What kind of crystal?
The time crystals.
I
time. You don't know them?
Don't know what that is.
Time crystals. You never heard about it?
Another thing. How do you spell time?
Time.
I don't know what time. Time is. That's a fixed thing. It's not. It's just like we have a 3-dimensional space. We have time that ticks on by seconds, what have you. These
Now,
are.
how about say with your lights? Are you pulsing them at a certain frequency band, or is it just?
I have. So this is a CAN device, and it's got a fast change and a slow change, and it's got some other things. It's got strobes, etc. But I go between different colors. Now, the devices that I actually control the LEDs, each LED by itself, I have different patterns that I'm working with, and so I haven't gotten back to that for a little while, but I want to vary the frequencies as fast as possible because I think that has better effect. And so I have a sequence like one frequency. I got a bank of 32, but I'm trying to go to a bank of 64. Of LEDs, and so you go from one color to the next color, the next color, the next color, all at the same time. So you got the LED flux of different lights that are coming at you, and you're varying them. You're continually changing from one to the next to the next.
Right.
So you're varying the LEDs, and there's also variation on the same plate of all the different LEDs. So you're continually changing the colors, and so that seems to be getting a better spin. So the whole thing is how can we get the best spin? And so having LEDs next to each other, it's sort of like having 2 tornadoes next to each other.
Right.
And so you got 2 vortices, and so you can get better speed up. And if they're sort of like a little different, you're going to get a little better spin in the larger space.
Right.
So that's the model, although it's complex to think about, and there could be all sorts of other patterns there, but that's the simplest thing. So I'm just going with the simplest patterns to just like with the capacitors I found out. Just go with the simplest plate on plate on plate. The industrial, they create capacitors or the crystals.
Now that device that you have there, is there any other ways of testing it other than physical health?
So you can sort of feel the energy. You can hear your voice going deeper and your lungs getting emptied and clean. But we do ice experiments. So you freeze the water, and you have the device on top of the water.
Right.
And so, typically without doing anything, you get this cloudy mess there, some cracks in it.
Right.
When you work with this and the different types of, so I've tried different types of this combinations, crystallite and orgone, and different devices, different lights, different capacitor type things, different crystals. And the combination and the higher the quality, the better results you get. So you get this sort of clear with this spiral in the middle. And you can see other people doing the same thing when they're doing their orgone experiments. And you can actually see the orgone guys, they put crystals in their orgone. Their orgone, basically some metal stuff inside an epoxy, which is a capacitor or orgone. I call it orgone because we don't have current going through it. So I don't want to confuse people by using the term capacitor. It also sounds, CLC doesn't sound as good as CLO. But it, to avoid the confusion. And so they too are now putting different waves in, and they get better results when they put waves in, like scalar waves or what have you.
Right.
So we're basically doing the same thing. They're basically, evolving into crystallite and orgone, but they're not describing that. They don't know the physics that I'm involved in, and so I do want to do a reach out to the orgone community and sort of, say, hey guys, you can, go in this direction, and this is other additional information that can help them. And it can be a community. Everybody's sort of interested in this stuff. So,
where are you publishing your papers? Are you using?
So I work, and so I don't. We have one paper on our simulations because one of the guys is more academic than me. So he put a paper together with my name, his name, and Paul's name on it. And he's like I'm the facilitator of our meetings, but he's sort of like the organizer. And he's the CEO of the Starburst Foundation that Paul used to, he founded. And so we have I have one of the papers on ResearchGate. Of course, I have some computer science papers on there too, and some journals, that type of thing. But for this stuff, I have some YouTube videos on meta level science. So you can go and look there. It's kind of old, but we're working on putting more popular things together because we're seeing vortical behavior everywhere. And so the presentation we want to give is sort of the introduction that I've given here. You see vortical behavior everywhere, and then just using some simple sense of continuous versus discrete, and having a model that is similar to like chemical models of reaction to fusion. You can model physics differently, and you can look at these components. You can do experiments with them, and so we're looking to do that. So in the meeting, we are gathering lots of data, and we're starting to do write-ups now too. Right now, the book Subquantum Kinetics, its 6th edition, is being published. Okay, so that's going to come out in the next month or so, and that's been like 6, 7, 8 months, maybe longer project. So and then we're going to go on to other things. So we have ResearchGate. Paul has some other papers there. Paul, he published papers on different sources and books and research journals, etc. He's got like 15 publications or something like that. And I got like 1 official publication in a journal. And then ResearchGate, we have some other papers, that type of thing. So that's sort of where we're publishing. And then YouTube, I've got some stuff that can sort of talk about the meta level science part. And also, one of the meta level sciences, I do a comparison of subquantum kinetics against conventional physics. So just go to YouTube and look up meta level science. You'll be able to find it.
Yeah, I already clicked on your link.
Yep, he's got his links in there in the private chat.
Okay.
The 1700 efficient free energy generator from COP28. That's pretty cool. Oh, by the way, Mike, did you check the Telegram channel I forwarded on WhatsApp?
I have a Telegram account.
I think no, I haven't seen that yet.
I didn't send it directly, but just on.
Okay, I'll have to go back to it.
Yeah.
Okay, so you see, you have spin. Okay, I see the link that you just put in us.
It's a free energy channel on Telegram.
Yeah, I don't know what it is if you don't put in the link. I can put the meta level science in the link.
Yep, you can put it in the link in the regular chat, or you can put it in the private chat.
I'm just recording some of the other links that were put in there. I'll just put the meta level science in there.
It's really good update. Yeah, it's interesting stuff. I've been really intrigued by Wilhelm Reich and what he was working on.
I'm working with him.
I actually have a web page that's meta level science, so you can. That's what I put in the link, and it takes you to the other links.
It's terrible. They burned so many of his books when they were prosecuting that guy.
Who is it? Right?
Wilhelm Reich. Yeah.
Yeah.
He was way ahead of his time, I think.
He did some very interesting stuff.
Yeah, the orgone motor. I've always been interested in how that works, and I found out what he called the Y factor. The Y factor is actually putting his hand on the device. He had to become part of the device for it to work. So I think the energy that's in our body had something to do with the reaction with the orgone generator that he made, and it was running a small little motor electrically, but it only would work the second he put his hand on it. That's what he called the Y factor.
So we have human life, so we have vortical behavior within ourselves. So sort of the things that I'm interested from this group is you're working with all these electronic components, and you're doing different types of research. Yeah. So using these concepts of vortical ether, basically, okay, so you've got something that's got vortical behavior. How can you improve that vortical behavior? And how can you chain it with other components that have vortical behavior? So, let's say we take a CLO device, which is a crystal like orgone, and we put it on top of, let's say, spinning spinning the Don Smith type device? Can you get even better behavior out of that? Or you can add spinning wires to or spinning some type of spin associated like scalar wave has got they have a lot of them that have got basically a circle. How can you add that? Well, and or within the electric circle, since I'm varying the light wave in space, but you can also vary the electric wave within a wire. So can you vary the electric wave in the wire to get more spin out of it, so that you put a constant.
Here's an interesting one you might not have heard of. Have you ever heard of the ball bearing motor?
I think I have.
It's two ball bearings with a steel shaft and a flywheel on one end. All right. So you got the metal ball bearings with the steel shaft and a low wheel on the end. And if you put current from one bearing to the other, so they say it didn't take much voltage, but it took a lot of current. So like 6 to 8 volts at probably about 8 to 10 amps. If you give that shaft a turn, the motor starts spinning. When in actual mechanical, when you look at this thing, it should not be spinning. So that high current going through the shaft from bearing to bearing is spinning inside the ball bearings of the setup and causing that wheel to actually turn. Eric Dollard actually did a conference. You could actually type it in YouTube. Eric Dollard and Chris Carson. They do a little a lecture, and they show this ball bearing motor. And you look at the damn thing and you're going, how the heck is this thing spinning? So the electrical vortices created obviously are creating a potential movement or force. It's creating a torque.
So with our model, there's some vortical behavior that's causing it, because the current conventional model doesn't really explain it. So go to the behavior. What's happening at the vortical level?
And the interesting part about it is it only works with DC current.
Okay. So that's the whole thing. I'm trying to say, hey, look at your devices, look at the vortical behavior, trying to optimize vortical behaviors, and try and chain types of things that have vortical behaviors. So that those guys who did that Don Smith device, it's a Korean company, and they present it to the WEF guys, and because they say, hey, you can create energy out of it. They had just 2 wires. They didn't have the spark gap or any of that. And they were, and one of the electrical guys in our group says that spark gap's really used to put things in sync. And so they're doing a lot of the sync via AI programs. And they have this physics models that they have very, very complex. I think they were talking about, we have 4 new physics models that we add in order to do all of this. But they were getting results. And my view is that you could probably get similar or better results by looking at it from a vortical ether perspective. I'm just saying that, I think the electrogravitics that people are talking about, the electrostatics, I think if they were to change and look at things from a vortical ether perspective, that would improve their behaviors dramatically. Because that's what I've seen in the device that I'm working on. I've seen people working with, orgonite and all this type of stuff, and saying you can get better behaviors if you start looking at vortical ether components and improving each of the component types. More industrial, so as opposed to creating your own little capacitor with metal shavings and an epoxy, and use ultra capacitors, and same thing with the LEDs. You can control the LEDs to get better spiraling frequencies.
Interesting. Yeah, because the standard electrical theory model doesn't even talk about this. That's the crazy part.
So the vortical ether, everything we're doing underlies regular electricity, and all these anomalous behaviors are saying it all has to do with the vortical behavior, and underlying all of this subquantum kinetics. Okay, so you can use Subquantum kinetics is a much better model because you can use it to model in many different ways. You can use it to model many different things. You don't just have to be stuck with electrical behaviors. It models electrical behaviors, but you can also model other things in that medium. So it opens things up much better than string theory or quark theory. It's a subparticle model, and those are the two predominant subparticle models are quark theory and string theory.
Well, you learn like Wilhelm Reich, he had this really good ability to look at nature, and even Victor Schauberger.
Yes,
with
spin. Spin,
right?
Yes, Schauberger was 100% water spin, and Wilhelm Reich he was creating capacitors, and he was really doing great research in that area.
Yeah,
yeah,
that's the sad part.
Did that, and we know that very clear.
You know, I know Schauberger eventually made his way to the U.S. in the late 40s, early 50s.
He did a trip. He did a trip here, and then he went back home.
Yeah.
He didn't have too much luck with his research, but I think the Germans used him to do one of their anti-gravity experiments, and they had some success.
Yeah, I think so too. Now, where the question is, where did that technology go to? Did it stay in Germany, or disappear?
You know, the whole thing is everybody's has this electrical model, so it's hard for them to get out. The devices that the governments have created, I mean, they can, you know, this might get a little political, but they have devices that can destroy buildings like 9/11.
Yeah, or you get into the right harmonic frequency of, say, a bridge. You know.
So what happened? I don't know if you've seen Judy Wood's book, but she basically, you know, did a lot of research, and she saw that there was this huge electrostatic field created around New York. And then there were these microwaves that are being used to just do things, just like Hutchinson.
Right. Yeah.
She talked with Hutchinson, et cetera. So she was basically saying it's the same model.
Right.
So you have this huge electrostatic field.
Right.
And just like with electrogravitics, and then you put more microwaves in it again. Microwaves have this big spin, and then you're basically disassembling everything.
Right.
You're spinning everything up to the point where particles.
Basically, mass just cancels out because you've messed up the entire spectrum.
Right. So as opposed to spinning things up to life, you spin it even more so that things start breaking apart.
That's right.
Massive. This is very harsh what they're doing, what they did. But it all ties together to vortical behavior. I don't want to give them ideas of between better destructive devices, but it's all behavior.
It's all related, yeah. Philip, did you have any questions for?
No, not. So far, I'm good.
Lulu, you got questions?
I'm good.
You're good.
Yeah, I'm listening.
Yeah, it's really interesting. This is cool. We had a really good discussion on what you've been working on. I've always had a soft spot for Wilhelm Reich, so I've always will read a paper that he did. It's that orgone motor that's driving me crazy. I want to learn how to make that. But the problem is a lot of that information was destroyed.
Do you have a link for that orgone motor?
Not on hand, but I could get it to you.
So just think of, you know, the orgone, it's basically a vortical ether component.
Right.
And it's not necessarily optimized, you know. You can use capacitors.
Yeah, like the device was about this size, and it was basically a capacitor, and then it had two wires coming out of it. And the second he put his hand on top of it, the motor started working. It was like his body completed the circuit. It's really weird. I've seen that, and I'm just like, how the heck?
Well, if you think of everything from a vortical ether perspective, life has vertical behavior in it.
Yeah, our life force energy, right?
Life force energy is vertical behavior. So I do a lot of qigong, and so a lot of these devices have been developed along with the qigong that I developed. And so people can sense the energy. Now, there's a lot of different types of energy in qigong, but nonetheless, you know, that's the view that, you know, you have all this blood going through you, so you have life force going through you, and you have that vertical behavior, you know, excess vertical behavior, and you put it on top of a device, and you could have additional vertical behavior, and that might be what's charging it.
Right.
And it's physics, okay, and it's the simplest model of physics that you could potentially use to explain a lot of these behaviors. Now, the detailed mechanisms, we're just starting to get into, like the detailed mechanism of how the chemistry of capacitors makes the vortical behavior, extra vortical behavior happen. We know that it has, and so we're talking with the chemists and say, well, how could we explain it? And then sort of
Right.
came
Now,
up
I have another question
you.
for you. In some of your experiments, have you been experimenting with, say, like graphene or graphite?
Mine.
Yeah.
I I want to, but I'm limited on my time, so
Right.
I'm a weekend scientist.
Yeah. Weekend site.
So
I
you
know.
said you have a group discussion on Saturdays, is that it?
So all of this is open stuff to investigate. Graphite, I know that people use it in capacitors and other types of devices, so I don't know how it would play, and I don't know what the chemistry model for it would be. So,
Well, in
all
the
great research topics for all the people out there, but let's move all these people who are doing orgone and Reich stuff to start looking at it from let's get the best capacitor out there, let's get the best waves, electromagnetic waves out there, let's get the best crystals out there, let's combine them together. How can we chain them? How can we turn vortical ether engineering or orgonite or what have you into the next electrical revolution? We had electrical revolution. I believe the vortical ether engineering evolution can be just as significant, if not more significant, than the electrical revolution that we had 150 years ago.
Yeah, it just seems like academia doesn't want to even like touch into this area because it goes outside their model.
Yeah, academia is not science. Academia is
a religion. It's a religion.
A cult.
There's one interesting thing. Back in the 1600s, people had experiments that showed that transmutation happened. And every 25 years or so since then, they've had similar new experiments showing in different ways that transmutation happens. It's been 425 years, 17 generations, and the scientists still haven't accepted transmutation because it's against their beliefs. So they have specific beliefs, specific models. I used to think the Christians, they said, oh, you guys are, you got your own beliefs too. And, you believe in science or whatever. Well, I do believe in science, but, you look at the models that you're using, it doesn't match the actual real world. And there's a lot of people who ignore the real world data because it doesn't fit with their scientific model.
Yeah. Like Salvador Payas, he has this saying, he says experimentation will always trump physics.
So you actually, because people learn in school, basic physics and basic physics models, and that's their view of the world, that their religion, and anything that counters that they don't like. And the problem is that there's so much research that counters what people were taught in high school.
Yeah,
right.
Massive amounts of research.
They call it theoretical physics. No, let's talk real physics, not theory. And that's why Salvador Payas says, actual experimentation will always trump the physics. Make the device first, get the effect that you're looking for, and then try to figure out the physics of how and why this works.
Applied physics trumps theoretical physics. When you have something that you're holding with your hand and it works, I don't care what the data or the science. Then, like you said, Mike, break it down to see how you can apply now the scientific theorems to it. But yeah, so yes.
Yeah, it took me 4 years to figure out how my Adams motor worked. Right, I'm seeing the effects. The motor's running and the batteries aren't dying. And even if I put dead batteries to run the system, it continues to run. So what's going on here? And it took me 4 years to figure it out.
Yeah. The only field that is not the only field in science that is still sane, I think, is computer science, because it's not tied to the Nobel Prize. You cannot win a Nobel Prize because of you wrote like the best software or the best
So engineering's real. I used to be a big, saying science, 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 and I got my PhD from an engineering school because the school I went to, the computer science department was in the College of Engineering. So I got it, my PhD in a engineering college, and now I'm out of it. It's like, yeah, engineering's real. A lot of the scientific models out there are really just theory.
Yeah, but think about it. Think about it. Computer science is still is still free from doing anything, which is good.
It's engineering.
Because look at biology. If you go in biology and you say, "Oh, the COVID was fake, is a big hoax," then you're gonna lose your job. Same thing in physics. If you say Einstein was wrong, you're gonna lose your job and blacklisted and so on. Same thing with chemistry. So the only thing left is computer science.
Well, no, it's engineering, all engineering, and computer science is engineering.
Yeah.
So look at the results.
Well, there's a difference. There's a software engineer. Computer science can do software engineering, but the true spirit of computer science is.
I'm not a pure mathematician. In AI, we see that there's lots of different AI models, different ways to doing AI.
Yeah, but the guy who invented AI and the neural network and the deep learning and all that, these are all
neural networks are they've got mathematical problems. They have bad model correlations with biology, so they have significant issues in and of themselves. It's a very they're very
politics.
It's not perfect, but it's a start.
It's like
we are using them to do things, but they have a lot of problems. They make a lot of mistakes. There's a lot of hallucination within them.
Yeah.
So they just rotely repeating what they're getting. So there's a lot of good AI models that do better than that on different tasks.
That's the ghost in the machine.
It's a huge discussion, what AI is. And so it too has a lot of the issues when you're getting into some of those AI techniques of politics and money too.
Yeah, but I'm just saying the guy who first came up with the deep learning thing, or the guy that came up with the MPEG compression algorithm, and things like that, or the image synthesis, the image rendering, and the image synthesis. That's what computer science is,
There's computer science is a huge field. That's a very small piece, and it is one of the techniques that's being used quite successfully. But they also have gradient descent and other things built into the models now. That base model has pulled in a lot of other AI techniques to make it more successful. And it's continually bringing in other AI techniques to make it more successful. So that's not really just the only piece of it, what the parts that you're talking about, neural nets. That's a small piece of it. In order to get the neural network to work more effectively, gradient descent and now other techniques are being pulled into it to make it actually, successful in the real world. But there are other people did other things, probabilistic models. There's all sorts of different techniques people have been using to be successful. That's just one of the ones that they've made very popular politically.
What about AI making electronic circuits, like AI generated circuits or switching circuits generated?
There's lots of different things people are doing, and there's lots of different techniques people are using, and combinations of techniques, like chaining techniques together, like chaining Rorke ether components together or electrical engineering components together. And it's fascinating. We're making a lot of progress. A lot of exciting things are happening and will continue to happen. But the stuff we've got now is
there goes the engineer's job.
Got issues from an AI perspective. We have lots of issues, but they're useful tools. Again, how can we use them to do tasks? And so a lot of the Gen AI that's very popular right now, it's useful for pulling information from a lot of different sources and then creating textual. It's predominantly a language model. Okay, so you can use it to do that. And I spent the last few months doing some Gen AI stuff, so I sort of understand some of the details behind that and some of the huge gaps. It's predominantly, basically doing language. And so garbage in, garbage out. And there's a lot of garbage out on the internet. And there's a lot of garbage coming from Microsoft and the guys who are making these Gen AI systems. So you're going to get a lot of garbage out of them. And people
How long do you think it'll take for all that garbage to get sifted out of the AI network?
Say again?
How long do you think it'll take for all that garbage to get cleared out of the AI?
Well,
to the point where AI is now totally ready to go and take all our jobs.
Okay, so the type of AI model they have has that problem. It's controlled by who puts the information in, and that will always be true. Whoever puts anything into an AI system,
we all know
they put
that.
garbage in, you're going to get garbage out. So there are groups who are going through and taking the base model,
the AI is not
and they're
supposed to
spending
just
time
take whatever,
getting the garbage out. And they're taking things that they say, okay, this is the real information. They're experts in this stuff and saying, let's take these models that are getting like 50-50, 50% of the answers are right, 50% are wrong, according to what they've been doing. And then they retrain it, and they're getting 90% right, 10% wrong. And some people are getting up to like 92, 93%. I think there's some of the data modeling stuff that was being done. They were getting up to 92, 93%.
So they retrain it with math, or how do they retrain it?
So they put text in, or they put data extraction formulas in. So people put different things into these things to train.
So they identify the junk and train AI to identify it as junk.
Well, no, they put real stuff in, and they train the AI to do the answers based upon the new stuff.
Okay.
Okay, and that gets rid of the old stuff that was, it slowly gets
and by default, everything else is junk.
Yeah, well, no, they if the new stuff starts overriding the old stuff, and they don't
default the new stuff.
They use the old stuff for the 50% that's still that's good, but they're putting new stuff in to get better answers. But they're getting like 90%, and even some of the best models, like data modeling stuff, I was seeing like 92, 93% in some of the experiments they were running. But that's based on current knowledge, so that's always going to be true. And you're going to have people who have different beliefs, and so they're going to say, "Oh no, your model's telling is 50% hallucinations, ours is not." And so it's people are programming these things and putting their own beliefs in. Okay, don't think anything different. And even there, there's still.
So it's not a glitch. So you're saying it's not a glitch in the machine or of any kind. It's just it's not. You're saying it's not a glitch in the machine, like they say, the ghost in the machine. It's actually people that are writing code that are not writing code correctly.
There's two different things. Okay, so there's the maturity of the AI system itself, which still has to evolve significantly, and people are putting other AI techniques into it, and they're evolving it. So like Envision, et cetera, they're putting other things to try and advance it. This is a huge advance that's happened in the last year or so from a language perspective, because now they can pull it out and turn it into text that's fairly understandable. So this is a big advance from a language perspective, but nothing else. So if you got somebody speaking gibberish, you're going to get gibberish out.
Okay? And what text are they using? English? What
language?
Chinese text?
You can create language. You can create different types of languages. So it's the same thing.
All the languages.
Translation. The translators are still quite. I'm learning Chinese. So
I you can translate to one text, then you can translate to them all.
So because I say, okay, I just read what they translated, and it's not what's written in the Chinese, but I don't understand Chinese well enough that I understand everything. So I still use the translators. So I see them all the time, and I'm saying, okay, that part's wrong, that part's wrong. But then
I hear China has their own software altogether.
Say it again, software.
I hear China uses their own software for everything.
They're following along very similar lines that we are. They're doing similar research. We're ahead of them in a number of ways.
Like all their routers and switches are on different software and stuff.
They use some of our stuff, they are writing their own stuff too. It's a huge culture. They got 1.4 billion.
Basically, what's yours is mine, and what's mine is mine. They take our open source, and
I mean, you could load this hardware with whatever EEPROM is in there. You can load it with whatever code you want to.
There's lots of different software being written, And so
there is a universal code though for there's supposed to be one for electronics. I don't think China and the West are playing along.
People design different electronic devices. I mean, in computer engineering, we learn how to design, the basic computer system, computer chips, etc. So, and there's lots of different techniques being used there, and there's lots of physics being used too. There's lots of variations that people are doing, and we are advancing, but we're quite a ways away from real reasoning in AI systems. They can do many. I always call it human computer intelligence.
And you blame that on the junk code that all the people wrote over there?
No, it's distributed human computer intelligence. So it's, again, a nominalistic view. Computers are tools. Humans do reasoning. Computers can do some reasoning. And the real intelligence is having a distributed group of people working with a distributed group of computer tools and reasoning together in a computational system. I've done some software programs, some startups on trying to build that type of solution where you're building that type of tool. And so and other companies have done similar things. And so you're basically trying to, get people who do reasoning, and they use computer tools to do reasoning, like CAE tools, finite element analysis tools, computer fluid dynamics tools, etc. So they do some reasoning with their computational tools. Information comes back, they make changes, it goes to another system, with another engineer, with other computers, and you have groups of these working together, and that's where you get real intelligence. That's where real intelligence happens. It's distributed human computer reasoning. That's what real. I don't like the term AI.
When you say human, what do you mean?
Human, us, our reasoning.
So we play a role in the AI somehow?
Massive. I don't like calling it AI. I like calling
so then it's not AI if we're still playing a role,
It's distributed human computer intelligence.
Oh, I get you now. All right, you don't like calling it AI.
Those AI systems, people are putting information in, they're controlling them, they're training.
Right. Okay. I see your point now.
I mean, some of the big things that people do is they train the system on how to ask questions.
Yeah. Search the internet or read books or whatever.
That they also, how do you ask the good questions to get good information out? So there's a lot of training around that also. And so all of the AI is really using a lot of human intelligence to evolve those AI systems. And it's definitely, all of it is distributed human computer intelligence. Okay, humans and computers.
What do you think it will take to get the computer to do that on its own without us?
It's reasoning. Well, it will always be best using distributed human computer reasoning. It will always be best with distributed human computer reasoning. The computer, humans, it's a combined. Just like we reason better as a group of people, it's always going to be groups of systems reasoning.
You can't count on AI as a collective because it's not a collective.
We're part of that collective, and now people are trying to combine the AI systems. And that's one of the things, like I built tools so that these reasoning systems we can combine. But in the end, it was, all these people who were controlling these systems. And
let me ask you a crazy question here. If AI had like a bunch of robots running the same AI in it, is that a collective?
No. Because when we're talking about software, we're not just talking about AI software. We're talking about finite element analysis tools. We're talking about a lot of different software tools that are out there.
Or if you just had all the servers in the world running the same AI, is that a collective?
That's not going to get you. You're going to be in real trouble. You really need a lot of other types of computational systems besides the AI systems. There's a lot of software engineering, other software tools that are absolutely central.
You need the dynamics for sustainability. You can't have one code, you're saying, one learning protocol, which would be AI, self-learning. Should I say one self-learning protocol? You can't have just one self-learning protocol, is what you're saying.
You're talking about
lots of different intelligence of learning. And people have made computational systems that do different types of learning. And they're all valuable. And some of the bigger systems, the AI systems, they use different reasoning techniques too. And they're starting to put more and more of those inside the system and doing all this chaining combined.
And each one of those reasoning techniques is probably an algorithm on its own, isn't it?
A lot more than just an algorithm. Very complex computational systems.
Well, it's
But,
multiple.
Great.
but the automated fields like law and being a physician and things like that can be replaced by AI. But
So
we,
I have very little faith in the medical community. The models and the physicians that I have most respect for have completely different models. And again, I'm saying all life is based on vortical motion. The heart is vortical motion, and so all the biological and health models are to help spin up everything. You're going to have better health the more you spin things up. Not just the heart, but getting that spin into the whole rest of the body. Herbs have more spin. There's dense energies being put into fresher foods and stuff like that. So the whole thing is to get better vortical behavior into your body, to the more healthy that you will be.
yeah.
So I don't have any faith in the current medical system or the medical models. And so I have a different view. It's like energy in the body, and the energy is vortical ether energy.
Yeah, and there's a lot of greed, obviously, in the law industry and things like that. So, but it's all automated tasks, so it's not the end of the world. But we're still far away from ASIs, like super intelligence and things like that.
Yeah, we're a long ways away, and in the end, there will be people controlling it.
Like
And
eight.
Yeah, why?
even
Well, you
people-
don't need
people.
people when you reach that level with the algorithms and the self-learning. You can't have people involved. You have to let it self-learn. What's the point in having self-learning if you're going to have people involved? That's like you want your kids to grow up and to be able to learn on their own at some point, right?
Well, you're talking about individual entities, but the real intelligence is the combination. And so there's intelligent people, there's intelligent computer systems. So you're always going to want to have a distributed human computer intelligence. And you can think, okay, how do we model?
You mean there always has to be oversight?
How do you model human
I
reasoning?
agree with that.
How do you model human reasoning? There's this model that it's in the biology. I don't believe that. I've been an AI guy. I've looked at cognitive science, and I see that there are algorithms that are done in the biology, but there's things that are not.
Intelligence is the capacity to abstract. That's what it
But you
is.
need oversight because you can't teach AI to learn, when it burns its hand.
So how do you model intelligence, human intelligence, in the physical world? Okay?
Yeah,
So one of the things that we're looking
it's
at,
like from that Star Trek episode where they gave Data the ability to feel, and all of a sudden now he's learning a lot more.
I'm going in a different tangent from where you are. Okay, so I hear what you're saying, and I'm saying, okay, you can look at it from the perspective of putting intelligence into physical matter, but you can also look at putting intelligence into the ether, and that's where I believe human intelligence and other intelligence is both in the biology and the ether. There are parts of it that are in the biology. You can see.
You're talking about God right now. If intelligence, it's in ether. Ether is some sort of
the ether, but you're trying to come up with a physical model to actually determine where that intelligence is, because we see lots of phenomena that intelligence does go outside of the biology.
I agree.
And
so, it's the same thing with
that would be the collective.
The evolution.
Be careful because connectivity. Okay, you have the collective, but it doesn't.
What is AI doing now? It's looking on the internet to get information. What is the internet? The collective.
But you only look at certain parts. Other people look at other parts. And so that's the thing. You have all of these filters that are going out there. So you have this huge network, but each individual reasoning system only traverses some of the links, and you organize things around some of those links. And so that's a big part of AI systems. How can you optimize the traversal of the links? And even within neural networks, you're trying to do that same thing. Trying to limit how many links that you go down, and trying to create a system that it reduces the number of links. Now they don't really have that much control. They sort of just randomly do that. But there are other systems that are trying to control it a little more effectively, like gradient descent. descent. They're using gradient descent to help build more organized networks. But there are other techniques of doing that too. So that's getting into a whole thing of AI. But the whole thing that I'm talking about, the ether, is how do there's reasoning in the ether, but there's also a lot of hallucinations in the ether. Okay, so if you go out to the ether to look at, just pull in psychic ideas or whatever, you get a lot of hallucinations. Just like in Gen AI, you've got a lot of hallucinations. Okay, the day that you ask a question, it gives you nonsense back.
It's
okay,
like
right, like solar flares and stuff like that.
All sorts of things. So it's not one collective; it's this whole large network.
You want to hear something crazy?
Entities that are traversing that. So if you're looking at human computer intelligence, what's the intelligence that's in the ether, and how do you combine that with intelligence in physical matter, in biology matter? Okay, so intelligence can be in many different places, and so how do you combine all those intelligences to have the most effective?
You guys heard about the network attacks on the news networks?
Oh yeah, that just happened. It affected my.
That was today, right?
It affected me and my workplace.
Yep, mine too.
Yesterday,
knocked out all the computers.
Yesterday, my TV
twitched
computers too. With my stove twice, but the power never went out. The day before this, yesterday, this happened. My TV was acting weird.
I can back in 5 minutes.
I'm using Linux, so I was not affected
with the stove.
I had a question for him. Yeah, I'm using Linux, and I installed Linux on my mom's computer, so our family is not affected.
Yeah, I know all the computers at my work were all down till almost noon.
I don't think it was no cyber attack. I think it was like a solar activity.
No,
it's a cybersecurity. It's a cybersecurity bug that can be removed. It's a .sys file, can take out, but it's a cybersecurity issue. It's not Microsoft related problem directly. It's caused by some antivirus thing.
Like it only affected the news networks?
Well, it affected my network at work, and we're behind a massive VPN.
A lot of planes got delayed because of that.
Yeah, that screwed up the airline industry big time today.
Yeah.
Well, I wasn't drawing a lot of power. I'm just saying when my TV flickered yesterday twice, I'm like, I'm not even drawing a lot of power. What's going on here? And it didn't go off. It stayed on.
There was a lot of solar activity today.
Twice.
I do have a tracker built on my cell phone, so if there's ever any X flares or M flares or any.
And last time the solar events happened, like a month ago or whatever, 2 months ago. I was feeling sick that whole time.
Yeah, it messes with your body too. A lot of people were saying that.
I was having psychic powers then, in the solar. I see things before they happen, so I don't ask me. It really does affect it.
Premonitions, you mean?
Yeah, I don't know. Whenever there's too many rays out there, somehow I get like or foresight, oncoming things and subtle little things, but they manifest, and so I don't.
Have you ever seen a premonition of me becoming rich soon?
Actually, I've seen us all becoming rich because of this. That happens. But
well, I played my lottery ticket tonight, so maybe it's a full moon, a really big full moon tonight. So maybe
get outside. It's gorgeous.
Yeah. Oh, it's the moon is huge tonight. Massive.
Nice. I gotta go outside later, take a walk.
Yeah, you should.
Yeah, it's pretty low in the sky right now. It's actually kind of weird, but it's a big full moon.
Yeah. I have a question.
It's funny. I was looking at it yesterday. I was like, "Wow, the moon's looking good today. What's going on here?" And now it's full. Well, how about that? Yesterday was pretty bright too. The moon.
If you guys could explain it to me, they brought a bunch of coils, so I'm actually trying to replicate it if I can. I got my little coils or my wire. Okay, so basically this is what they did. they brought this wire and they made it into a circular motion, and then like a lot of it, and then they tied it from both ends so it becomes like a circle. They put a battery, and then they put two magnets on each side of the battery, and the battery started going in circles inside of the, you know, the like the wrapped wire, like it's going to be like this, but just many turns until it becomes a circle. What kind of motion is that? Because now the battery is moving as if it's like a, you know, on a track. So I'm going to replicate this. I'm going to try to get this done tonight, and maybe for tomorrow for the live APEC, I might want to present it to see. But what kind of motion is that?
The electron is discharging into the metal material and creating the flow.
Okay.
From the battery, the electrons from the battery. It's
Okay.
a discharge.
Okay, so discharge. Oh, got it.
Because when you discharge the battery, it creates electron flow, which will then generate probably some kind of magnetic effect on the ring. Is it copper?
This one, yeah, it's copper. Now I've got this.
Yeah. I'm not sure. Isn't that the monopolar thing?
And then I have
Have you guys ever heard of the Faraday motor?
now I've got this guy, like these wires here. They're like gold wires, really cool gold, like 18 karat gold wires. I think it is 18 karat. Yeah, it's gold or 11, 18 gauge.
Right. So yeah, the loop of wire, when the battery makes contact, it energizes the coil, and the coil makes a magnetic field. If there's any iron in the battery, it will move the iron in the battery. If the battery has iron as part of its structure, and the magnetic field of the copper that's generated, that magnetic field will push the iron or turn it.
What would the magnets be doing?
Oh, you have magnets too. That'll even more magnetic field. So they're opposing or attracting the copper's magnetic field, because you have the battery too, right?
Yeah, like just
So the battery is helping you hold the terminals to the copper, so you have good connection, and also increasing the magnetic field that's generated on the copper, make it stronger, probably.
So, question: when the battery runs out of juice, does it
I've never replicated that, but I've seen those things. They call them the monopolar motors.
Would that work perpetually?
Yeah, they work. They work. It's just like a neat little way to make a pulse motor, I think.
Okay.
Are you talking about the Faraday motor?
No. You know where you take the 1.5 volt batteries inside
Yeah,
of it?
that's a Faraday motor.
Yeah, that.
Yeah. John Bandini did that. It takes a lot of current to run those. So that kind of proves that there is a spinning going on in the Faraday motor.
Well, I'm gonna try tonight and see, like if it works, then.
Oh, it does work. Yeah, you just have to get those wires in the right position.
Yeah.
So you could take one of the big D cell batteries, because they got a lot of juice.
Use rechargeable batteries.
Or whatever. It doesn't really matter. That's kind of irrelevant. But you need two big neodymium magnets below the battery on the negative side, and you curve that copper wire around the battery to where the two neodymiums join. You create like a ring using the same wire. It all has to be bent in one shape, in one piece. If you get it right, they all start spinning.
Oh no, that wasn't what I was trying. Saying no, you misunderstood. Then, hold on. Let me see if I could get. Okay, so I was trying to use this thing to wrap this thing around, and come on. All right, wrap it into many loops until I get like a bunch of them next to each other. See?
You're not showing your screen.
Can you see it?
No.
Yeah, you have to put screen share.
Okay, I don't know if you can see it closer.
Hold on. put you in solo here.
Okay. This thing, if I could get this wire around it, like many loops, to the point where I have like a helix, like, and then attach the two ends into a circle, like an orbit, but in the center of, the wrapped around coil, this thing, put a battery right there, like a small battery, and then put two magnets, one magnet on each end, and the battery's supposed to, like, go like in circles in,
Oh, I see what you're saying. Yeah.
yeah.
Well, it's a closed circuit for one. Your battery's going to heat up really fast.
Okay.
Because basically you've created a dead short.
Okay.
But if it was pulsed, you had control over it, yeah, you could get the spin going around that circuit. But
Okay.
yeah, to hook up a battery and short it out like that, yeah, it's not a good idea. It will heat up on you.
I don't know. I saw it and I thought it was a pretty cool, nifty idea. If it,
Well, I mean, it'll run for a little bit, and then the battery goes, it'll heat up, but it won't, run out of energy, and then you got to recharge it.
it will run out of juice. It's not the perpetual.
Yeah.
No, it won't be. No.
That's why I say use rechargeable batteries.
Yeah.
The only problem is that your battery is going to heat up because you're basically essentially creating a dead short with the battery.
All right. Well, I'm still gonna try it to see.
Just be careful.
It'll look really pretty. No, I'm gonna use a 80 battery. I'm not anything, big.
If you notice the battery heating up, stop doing it.
Just pull it apart.
Yep.
All right.
Hey, Justin, I have a question for you. So Darwin's natural selection law that animals evolve because the weakest one die and so on. But I think it's more than that, because I think when you look at the animals, there's a form of intelligence in the evolution of the animals, and just the fact we have two eyes and not one to calculate the distance and things like that. It's a form of intelligence.
So there's models of punctuated evolution, and that and there's some research behind some of this, that the species learn something new and then they put it in their evolution. They
change their own ADN.
So the question is, how much of our genetics is in the gene and how much of it is outside the gene? And so there's this whole field, epigenetics, and it's starting to becoming a dominant model in biology, that there's this controlling information that's outside of the gene. Now they've made proposals that it's in the that there's light, that's being passed back and forth. That there's within chemistry and biology and within cells, light or sound or electrical information. It's not just the chemistry that's controlling the biology. So there's a lot of different models out there, but the whole thing is that they're basically saying that, yes, there's other information, that the genes are basically plans, but the decision on which plan to use is done elsewhere. And so that the genes can only carry so much information. So, we're talking about information in the ether. And if you look at the morphogenic field by Rupert Sheldrake, he shows lots of different evidence that there's information and reasoning that's well outside of the biology, that there's some type of Akashic record, or there's information in the morphic field. And I don't know why people would think that's surprising, because all of our computers run, on, cell towers, etc. We're sending information through the ether all the time. Okay, electromagnetic fields are sending information all the time. So the only difference is, well, it's not just information being transferred; it's actually in the ether, contained somewhere. Where is it stored? Is it stored among all the separate entities, or is it stored in something beyond that? And so,
but just think about the chameleon. The chameleon can change its skin color.
And so all the information. So all the information for what you're talking about, where is it stored? Okay, so it's not in the genes. And so there's some reasoning happening, maybe in an entity, in a species, and then that information sent to all the others. And it's not necessarily stored in the genes; it could be stored in
Capacitance.
the morphogenic fields.
Yeah.
The ether has capacitance. Why wouldn't it? Why do you guys don't think that the ether has capacitance? Probably the most biggest capacitor known to the cosmos.
Right. And I don't want to get into subquantum kinetics too detailed, because that's really getting
No, I
deep.
mean the ether can hold
Right. And
energy.
there's different models. There's different etheric models of how that information can be stored. And so you want to have a good model.
Information.
We're seeing all this data, okay, that yes, there's information that appears to be stored up in the morphogenic field. So how is it? What's the model? What's the physical model? And subquantum kinetics enables you to model. And that's the thing. You want a model that allows you to model the phenomena that we observe in the real world. And so, yes, that what you're talking about is punctuated evolution or intelligent evolution at the individual and species level, not at the God level. Okay. And so that, it's still an evolutionary model, and there's some intelligence associated with it. And we're not talking about God, from a nominalistic theory perspective. God is way out there. We're just working with tools at our level. It's nominalistic. What tools can we do and create and reason with? And those bigger questions somebody else is doing. We're just doing nominalistic tools. Okay. Nominalistic models and reasoning. Those are the questions are bigger. We don't want to get there.
Exactly. Well, Justin, thanks a lot for coming on tonight. You really gave us a really good thing to think about, and all the stuff you've been working on. I'm definitely going to.
Well, I'll come back in a few weeks. I want to ping you guys and see what you guys think of, the vortical, all the electronics that you're doing, and how you can incorporate vortical ether into it, because we're starting to look at that. We're starting to look at the same things you're doing in our meetings on Saturdays, which are long. And so, there's a lot of crossover, because in the end, it's what tools that you can make from a utilitarian perspective.
It's the engineering. It really comes down to actually engineering it.
Things we can actually turn into DIYs, things that we can actually share with other people, so other people can build their own.
Yeah, exactly. And I'm very big on that. And probably a lot of people listening are big on building stuff for themselves, and the DIY.
Yeah.
So I'd love for you to come back on. We're on every Friday night at 9 o'clock Eastern. And everybody, thanks a lot for joining us tonight. Any questions, comments, you can always leave it at Faraday Research YouTube channel. And I'll be posting some links that Justin has given to me here in the private chat. And any words before we take off for the night?
I want to thank you, Mike. Okay, I want to thank everybody else too.
Yeah,
I don't remember everybody else's. Phil and I think there's two Mikes here, right? Mike Dose.
Yeah.
Mike 1 and Mike 2.
And I don't know your name, our lady friend here.
Lulu, and we got Philip.
Lulu, Philip, Mike, and Mike. Okay. I want to appreciate your time. I want to wish you a most wonderful week or a few weeks until I next see you. And all the audience too. I want to wish you guys all successful and wonderful weeks also. And thanks.
Yeah, awesome. Thanks. Thanks everybody for joining us. Also, our live chat tonight was really active. Thanks a lot, everybody, for making it definitely a very entertaining show. And we'll see everybody soon.
Thank you, guys.
Have a great week. Take care.